For question number 12, the first thing I would look at is, are we trying to maximize something or minimize something? And if you read the problem, we're looking for the least amount of paper. So what we're trying to do is minimize the amount of paper. So what should the dimensions of the paper be so that the least amount of paper is used? So I'm going to try to minimize, well, to think about the paper, it's really the area equals length times width. And the question is, what's the length and width going to be? And then we're given this other information, and I am going to draw something. I know it's going to be a rectangular sheet of paper, and I know that we need 24 square inches of print. So this is 24 square inches, but I don't know if it's going to be arranged 3 by 8, 4 by 6, or whatnot. The margins at the top and bottom of each page are 1.5 inches. So this is 1.5, 1.5, and so forth. So I'm just drawing in what I know. The margins on each side are 1 inch, so we have 1 there. And here's what I am going to say. I'm going to say this is my paper, so this is length, and this is the width. Okay, so I'm trying to minimize that, and what I also know is that I have this 24 square inches that I'm going to use in the center. Well, that's the area of this rectangle. So my other little bit of information is that, well, in order to figure out the distance from here to here, I'm going to have L minus 2. And my distance from here to here is W minus 3. So that, in fact, is 24. And this is the big setup. So here's my objective function. Here's the other bit of information. Now, again, I need to get the objective function in terms of one variable. So I'm going to try to solve for, I'm going to solve for L. So I'm going to divide both sides by W minus 3. So I have L minus 2 equals 24 over W minus 3. And then I'm just going to add 2. So L is 2 plus 24 over W minus 3. So now my objective function is W times 2 plus 24 W minus 3. And I have no idea what this looks like. I do, in fact, know that there was going to be a vertical asymptote at 3 because of the W minus 3 in the denominator. And so I need to figure out what the domain is. As far as my width is concerned, well, I know that the W has got to be at least greater than 3. This tells me so, but also I know I'm going to have 3 inches worth of margins at the top. So I'm going to say that my domain is 3. And really, I can go all the way, I believe, to infinity. As W gets longer, L is going to get shorter. Oh, wait, I take that back. The shortest that L can possibly be is 2. Yeah, I'm going to say 3 to infinity. Okay, and now comes the moment when we have to graph this. And you need to just watch parentheses here. So I am going to plug in, let's see, we're going to have X instead of W times, and then we're going to have 2 plus 24 divided by, and now the denominator needs to go in parentheses if you have an old calculator like I have, and then I need to add another set of parentheses. For my window, I'm going to go from, I kind of like to see the asymptote, so I'm going to go from 2 to, I don't know, maybe 10. I'll make Y max. I'm just guessing 25. Look for a graph. Nope. So let's just test a value. Let's suppose I plug in vars, y vars function, y sub 1. Suppose I plug in a 4. Oh, that's up to 104. If I plug in an 8, that's 54. So I'm going to set my window. I'm going to make my y max. I'm going to try 150 and see what that looks like. Okay, so it's coming down, and I'm assuming it's going to go back up. So I think I need to expand my x max. Okay, and we're looking to minimize our area, so that's what I'm looking for. Again, I'm going to do second calc, minimum. I'm going to get a little to the left. little to the right. And so you can see that the minimum is going to be at W is equal to 9, and our area is 54. So let's just go back and make sure we're answering the questions. What should the dimensions of the page be? So W is 9, and so our page should be 9 inches by, and let's see, if our area is 54, then I know my length has got to be 6 inches. And that's our answer.